All right, we are going to walk through our first lab, detecting signs of a chemical change, and this is info I'd normally tell you when we walked into lab and got started, but we're going to be short on time for some of the groups, so this quick video will walk you through all of that, so when you come into lab, that you'll be exactly ready to go. You won't have to wait on me to tell you to get started. You'll come in, you'll get started, you'll have everything you need at your station, and you can simply begin. And how you will begin is with your procedure right down here on page 2. You will just walk through all of these experiments. There are 6 experiments step by step. So what I'm going to do though is I want to remind you what the lab is about and what you're trying to observe and give you some tips for how to observe those things. So the lab is called Detecting Signs of a Chemical Change, okay? So we're going to be looking to determine when we mix things together in our test tubes, you're going to do 6 experiments, do we get a chemical change or no, all right? So let me tell you first off, you're not always guaranteed a chemical change, all right? You can mix things together and get no change, so don't force yourself to see something that isn't there. So if you mix things together in one of your 6 experiments and you don't see anything, just write no change, okay? But here are the 4 signs of a chemical change that we talked through in our very first lecture. So I'm going to go through these step by step. The first one right here is a color change. All right, now, first off, I want you to notice, it does not imply dilutions. A dilution is not a true color change. So let's say you have a green mixture or green solution, and then you have a clear liquid as well, and you mix these two together, and then you get a pale green. Well, you simply diluted the green color, so that's not a real color change. A real color change is you mix something that was yellow, and you mix something that was clear, and you get something that's red, okay? A real color change is going to be completely different, all right? Now, I'll tell you, there are times you're mixing liquids, and then there's times you're mixing a solid and a liquid. So you have to observe both things. Did my liquid change color? Did my solid, okay? I think your solids in this experiment are metals. So assess both. Did my metal change color? Did my liquid change color? And then if neither one did, you won't write that down. But if one of the two did, both things don't have to change, but at least one thing changed colors, you would write that down, color change. All right, formation of a precipitate. What is that going to look like? I want to read this carefully. Is when 2 solutions are mixed. There's a criteria, there's a requirement here. You have to be mixing 2 solutions, which are liquids. If you are mixing a liquid and a solid, you're not going to form a precipitate, okay? A precipitate is when you mix 2 liquids and you get something solid, right? So keep that in mind. What are you mixing in your experiments? It must be 2 solutions, not a solution and a solid that is mixed for you to get a precipitate, okay? A precipitate is a solid that is dispensed throughout a liquid, all right? So it may settle at the bottom, so you might want to sit that test tube to the side for a few minutes after you do the experiment and see if it settles to the bottom. It may appear as a cloudy suspension that does not settle at the bottom of the tube, okay? So do the experiment. If you think you formed a precipitate, give it a few minutes, come back and look at it. Did it settle? Did it not settle? Was my liquid clear and now it's cloudy? That would be good indication that you formed a precipitate, okay? Evolution of a gas. So this may appear as small bubbles in a solution. Well, bubbles, let's talk about these. If you drop a piece of metal into a liquid and you see a splash and one little bubble, that would not necessarily be considered evolution of a gas. This is going to be vigorous. Vigorous, okay? A lot of bubbling. All right, and you have to look close. Sometimes if it bubbles so much, it may appear cloudy to students, all right, and they may think it's a precipitate. So you need to ask yourself, if something is bubbling so vigorously that it looks cloudy, did I make a precipitate? Did I mix 2 liquids together? Or is it just bubbling? And it's so vigorous that it looks cloudy, but it's just the bubbles, okay? Then lastly, a temperature change. Okay, and this is without adding any heat or adding any, putting it in a cold environment. It's produced by the chemical reaction itself. So how are we going to observe number 4 right here? Well, you're going to have to be feeling your test tube, okay, with your hand. So the test tube will only contain 1 or 2 mLs of your chemicals. So down at the bottom. So don't be holding the test tube just at the very, very top. You're going to have to, so for example, if here's a test tube, Okay, your stuff may be down here just at the bottom. So you're going to be needing to feel the test tube down here in this zone, okay, not just holding it up at the top. And you're going to be feeling for a increase or a release of heat, or if it gets really, really cold. Now, I'll tell you, this is not going to be faint, okay? You're not going to have to wonder, did it not? It'll be very, very obvious if it gets hot or if it gets cold. Now, the room temperature will also affect the temperature of the glass. So when you begin all these experiments, the glass already, your test tubes, your glass test tubes, may already feel cool to the touch. Okay, so keep that in mind. The temperature change will be very obvious. It'll get very hot or very cold, okay? Now, if you have any questions about these 4 things and what you're seeing and what you're observing, please call me or the TA over. We'll have a TA in there as well. We're happy to talk through anything with you, to discuss anything, to help clear up any confusion, okay? Because sometimes students do get confused on these, even though they sound very straightforward on paper, all right? But now I'm going to scroll down and address a few more things before I end this video. By the way, you need to be taking note of anything that has a hazard associated with it as part of your pre-lab, okay? Hydrochloric acid is corrosive. Copper sulfate right here is toxic. So keep in mind when you're working with these particular solutions, okay, these are your 5 experiments. It tells you what to do step by step for every single one of these. But I want to get down here. This is your pre-lab. I want to go all the way down to your data sheet. Okay. So if you have the procedure pulled up on Blackboard, please be looking at this with me. Here's where you're going to write down your conclusions. All I want you to write down is a bullet point statement, okay? You're only going to see one change, or I should say one piece of data for each experiment. Except for one of these. So so I should say one change for 5 of the 6 experiments. Okay, one experiment will have 2 changes, 2 things you'll observe, 2 observations. All right, so you're only going to write down one of an observation. Okay, one change for each of these experiments, except for one of them. One of them will have 2 signs of a chemical change. Okay, and again, if you don't see anything, just write no reaction, no change. So that's your data sheet. You don't have to write sentences or paragraphs, just your brief statements, one of the 4 things above. Here's your post-laboratory questions. Again, these will be on Blackboard. They're going to be multiple choice questions when you go to do them on Blackboard. So feel free. Read over these and write down your answers, and then see what it best aligns with on Blackboard when you put your answers in on the Blackboard assignment. Okay, that's it. I'll see you guys in lab, and I'll be there to help answer questions as we go along.